Welcome back, everybody. This is going to be part 2 of 3 in my lecture series on composite functions. If you haven't seen the first part, please go and watch it now as it's going to be important for this part. In this video, we're going to learn about some more function notation that will help us express these composite functions. Let's get started. Let's suppose that f and g are both a couple of functions that we have. Sometimes we need to add, subtract, multiply, and divide functions, and we have notation to represent that. And it's pretty straightforward. When I write f plus g, I mean literally f of x plus g of x. Same thing for minus, same thing for multiply, same thing for divide, so long as the denominator function isn't 0. So let's get some practice with using this notation. Oh, and let's get that keyboard out of there. Let's suppose f of x is the square root of x, and g of x is 1 over 2 minus x. Let's compute each of the following and then find their domains. For f plus g, for this problem, we literally just add them together. The square root of x plus 1 over 2 minus x. In part b, we just subtract the 2. Square root of x minus 1 over 2 minus x. In part 3, we multiply the 2, root x over 2 minus x. And in part d, we divide the 2, root x times 2 minus x. And I'm getting that by multiplying by the reciprocal of g. Go ahead and pause the video here to see if you can find the domain of each of these functions. In parts A through C, they all have the same domain. 0 to 2, including 0, but not 2, and then 2 to infinity, excluding the 2. But in part D, just 0 to infinity, including 0, would be the domain. In part A, I got that by noticing, under the radical, that thing, which is x, has to be greater than or equal to 0, and in the denominator, 2 minus x can't be 0. The same logic applies to parts A, B, and C. In part D, though, I no longer have a denominator to consider, so I just have to worry about the radical. In this video, we saw how to add, subtract, multiply, and divide functions, and how to use the according notation. In the next video, we're going to continue this process by looking at some notation for compositions of functions. Catch y'all in the next one.